Hi everyone. Welcome to Workshop 5, Introduction to Data Center. I'm YG, your coordinator for today. I'm pleased to introduce Leng Koon, a lecturer in data center operations and infrastructure. With a solid background as an M&E engineer, Leng Koon has extensive hands-on experience working in data centers and construction sites. This unique combination of practical expertise and academic knowledge makes her a valuable resource for students and colleagues alike. Please submit your questions during the Q&A function located at the bottom of the Zoom window. Questions will be addressed at the end of the session. Please join me in welcoming Leng Koon.
Good morning, everyone. Wherever you are from, it's a real privilege to be here with you today. My name is Leng Koon. I'm teaching in ITE College East. I spent a considerable amount of time exploring the fundamentals that power our digital world. And that brings us to our core topic for today, an introduction to data center. What we will cover today, we will unveil data center. We will talk about what is data center, the importance of data center, the application of data center, and the key component of a data center like the IT equipment, power infrastructure, cooling system, networking and connectivity, physical security and fire suppression system. Then we will talk about the monitoring system like the BMS and DSIM system. We will talk about what types of data center, their roles of data center in today's world, and finally, the challenges and future of data centers. Imagine a world without Google, Facebook, Netflix, online banking, or even your favorite mobile apps. It's almost impossible, right? All the online services rely on a hidden yet massive infrastructure working tirelessly behind the scene. We call it data center. By end of this hour, I hope you have a solid understanding of what data centers are and why they are critical and how they power our digital life. Have you ever wondered where all your videos, online shopping spree, and mission-critical business data actually live? The answer lies within the data center, the unsung heroes of our digital world. These dedicated facilities house the powerful computer systems and intricate networks that underpin everything we do online. One such example is the telecommunication and storage system. You can think of them as the physical infrastructure that makes the internet and cloud computing a reality. But to ensure the IT operation is running uninterrupted on a 24/7 basis, the data center must be designed to be highly secured and in a controlled environment. The key purpose of a data center is to centralize an organization's IT operations and equipment, as well as to store and manage its data. So why are data centers so crucial? Data explosion. With the emerging of social media, streaming, and AI, we are using more and more data than ever. Data centers provide the necessary infrastructure to house all the data, especially for AI data. Continuous operation. Users expect service to be available constantly. Imagine waking up in the middle of the night. You find it hard to go back to sleep. What is the first thing you will reach for? Your handphone. How would you feel if you cannot access the internet? Data centers provide the reliability and redundancy needed for continuous operation. Processing power. Running complex applications, simulations, and AI models require immense computational power, which data centers provide at scale. Security. We have to protect sensitive information from cyber threats and physical damage. And finally, efficiency. Consolidating resources in a controlled environment like the data center is more efficient than scattered IT infrastructure. Let's look at the applications of data centers. We have the cloud computing. They are the backbones of services like AWS and Google Cloud. Online services, powering website e-commerce platform like Amazon, eBay, social media like Facebook and Instagram, and streaming service like Netflix and YouTube. Data center also provides securely processing transactions and managing financial data for financial institute. Enterprise IT, they support internal operations for businesses of all sizes, like CRM, customer relationship management, which is a software system designed to manage and analyze customer interactions and data throughout the customer lifecycle. Healthcare, data center stores patient records, medical imaging, and research data. And government and defense, critical infrastructure for national security and public services. Data center is a complex ecosystem. We can categorize the component into a few main areas: IT equipment, power infrastructure, cooling system, network and connectivity, as well as physical security and fire suppression. When we talk about a data center, we are talking about the brain and storage, the IT equipment. What are the major IT equipments? We have the server, which is the core computing machines. They are specialized computers designed for continuous operation and often rack-mounted. You can think of them as super powerful, purpose-built computers. We have, secondly, the networking gear, which is your switches, routers, and firewalls that can connect all IT equipment and provide external connectivity. Next is the storage system. This is where all data live. This includes hard disk drive, which is your traditional magnetic storage, solid state drive, SSDs. They are the faster flash-based storage that is commonly used nowadays to replace the hard disk drive. Storage area network, dedicated network for storage, and then network attached storage, which is your file level storage accessible over a network. Power is very important to a data center. Power is like the human heart that keeps the whole operation running. Let us talk about the power infrastructure for data center. Main power supply for data centers comes from the main utility grid. Transformer will convert the power from the utility grid to a lower voltage suitable for the data center. But when there is a power outage, diesel or natural gas generator provide long-term backup power during extended outage. We also have the uninterrupted power supply here. They are also called UPS. They provide immediate backup power in case of utility power outage, bridging the gap until generators kicks in. Next is the power distribution unit. We call it PDUs. They distribute powers from UPS and generator to individual server racks and equipment. Often, power systems are designed with an N+1 or 2N redundancy, meaning there's always a backup if a component fails. In this case, UPS have a redundancy of N+1. This is a 2N redundancy design. Instead of having one more component as backup, there are two sets of power system with the main power supply and secondary power supply as backup. So we have explored how configurations like N+1 and 2N are designed to build resilience into our systems. What is the goal of implementing such robust redundancy strategies? It's all about ensuring uptime. Uptime is simply the measure of how long a system or service is operational and available to user. In our always-on digital world, every second of downtime can mean lost conductivity, lost revenue, and damaged reputation. By understanding and deploying N+1 or 2N, we are actively striving for maximum uptime, giving our user and businesses the continuous access they can depend on. Next, we will talk about cooling system. IT equipment generates a tremendous amount of heat. Without proper cooling, equipment can overheat and fail. Water-cooled chiller systems are normally used in the data center for cooling of the IT equipment. We have the cooling tower here. They will send chill water to your chiller, then to be used by the CRAC unit, also called computer room air conditioner, and CRAY unit, computer room air handlers. CRAC and CRAY are specialized units that cool and circulate air within the data center. There is also an emerging trend to make use of liquid cooling for high-density environment by directly cooling server with liquid. To further improve the cooling efficiency, we designed the layout to separate hot exhaust air from cold intake air. On the left-hand side here, we have the hot out containment. The back of the server is enclosed in a containment. The back of the rack will generate heat, and this heat can be contained within the hot out containment. This is the hot out containment. The hot air will then be channeled back to the CRAC or CRAY system via a duct, force ceiling or chimney. The air outside the containment will be cold. So this is perforated floor tiles. The air escaping from the CRAC unit or CRAY unit can escape from the perforated floor tiles and goes to the front of the panel. And then they will go to the back and then back to your CRAC or CRAY unit again. On the right-hand side is the cold out containment. Instead of enclosing the back of the rack, we enclose the area with cool air escaping from the perforated floor panels to cool the front of the rack. The air outside the containment will be hot air. Perforated floor tiles are floor tiles with holes so that the cool air can escape from the floor tiles. Next, we will talk about the networking and connectivity. Networking and connectivity is like a digital highway for data center. When we talk about networking and connectivity, the first we will talk about is the internal network. They are the high-speed internal network, like your Ethernet and fiber channel, that connects servers to storage and other internal devices. External connectivity, high bandwidth connection to the internet and other data center like the fiber optics. Router and switches that direct data traffic within the data center and to the outside world. Firewall and security appliances that protects against unauthorized access and cyber threats. We also have the redundant link that provide multiple paths for network traffic to ensure continuous operation even if one link fails. Physical security. To ensure the data is kept in a secure and safe environment, unauthorized personnel should not be allowed entries into the building. There must be security around the perimeter of the data center, like fencing, gates, and bollard. This will prevent unauthorized personnel from entering the data center. Doors entering the data center or IT equipment room can only be accessed via access control like biometric scanner or keycards. Lift serving individual floor can only operate with the use of access card. There will be surveillance like CCTV cameras around the data center, providing 24/7 monitoring. On-site security guards will also patrol the data center 24/7 to watch out for anything suspicious. Fire suppression. There are smoke detection systems around the building to provide early warning of fire. Fire extinguisher is also within sight for manual intervention if there is a fire. We make use of gas-based fire suppression system like your FM200 or your Novak 1230 for the power or IT equipment rooms, as non-water-based agent can non-water-based agent, they can distinguish fire without damaging sensitive IT equipment. Water sprinklers are generally avoided where possible due to equipment damage. Building management system is one of the monitoring system for data center. We also call it BMS. BMS system, they controls and monitor things like the cooling system, fire detection and suppression system, security access and power distribution for the entire building. You can think of it as ensuring the data center environment is safe and stable for operations. Data center management system, we also call it DSIM, they take the steps further, focusing specifically on the IT infrastructure within the data center. It provides a holistic view of all your IT assets, like your server, your storage, your network devices, racks, PDUs, and environmental sensor at the rack level. DSIM helps to optimize energy efficiency, capacity planning, and asset management by giving you real-time data on power consumption, temperature, and space utilization. Essentially, this BMS handles the building aspect, while DSIM drill down to the IT infrastructure and its immediate support system within the building, often sharing data with BMS for a complete operational picture. Next, we will talk about the types of data center. First is the enterprise data center. These data centers are owned and operated by a single company for its own internal use, like the bank data center, Another example is Microsoft. They also own their own data center. We also, secondly, have managed service data center. They are owned by the third party and leased out to multiple companies. The provider will manage the infrastructure. The third type is the colocation data center, in which a third party provides the space, the power, the cooling, and security, but the customer owns and manages their own IT equipment. The cloud data center will be massive facilities owned by cloud provider like AWS that offer computing and storage resources as a service over the internet. We also have edge data center, which is smaller data center located closer to the end user to reduce latency, often found in remote location or urban areas. What is the role of data center in today's world? They drive big data analytics, especially with AI nowadays. They enable organizations to derive insights from vast data sets, improving decision-making, personalization, efficiency, innovation, and predictive capabilities. Enabling digital transformation. They are the foundation upon which business innovate and adopt new technologies. For example, cloud computing enables scalability. AI enables insight. Powering the Internet of Things. Processing and storing data from billions of connected devices. Internet of Things is like when your refrigerator can tell your phone when they are low on milk. Data is processed, often in the cloud, and then used to provide insight, automated actions, or enhanced experience. Supporting remote work and collaboration. Ensuring connectivity and access to applications for distributed workforce. They also facilitating AI, artificial intelligence, and machine learning. They provide the computational horsepower for training complex AI models. Singapore government initiative for green data center include renewable energy like solar, wind, that can help to manage better energy efficiency in operation of the data center. Management can investigate renewable energy options that can help company to grow greener. We have company like Equinix, a major data player in the data center space that have signed multiple power purchase agreement in Singapore to utilize solar energy. They are working with Sembcorp Power to source solar energy from JTC's properties on Jurong Island. This initiative will cover a significant area of vacant land and rooftops of building with solar panels. Digital Reality has also installed solar panels at its data center in Singapore and has planned to expand this initiative to other facilities. This is part of their broader strategy to reduce reliance on non-renewable energy sources. ST Engineering and Meta are also investing in a new sustainable data center that can feature a large area of solar panels on its facade. These are just a few examples of how data centers in Singapore are incorporating solar energies into their operations. As Singapore continues to push for sustainable practice, it is likely that we'll see even more data centers adopting solar and other renewable sources in the future. So what is the future trend of data center? Green data center. Mainly focusing on renewable energy, energy efficiency, and water conservation. Data centers are massive consumer of electricity and increasingly water for cooling. As the digital economy expands, the environmental footprint of data center is also growing. Green data centers aim to mitigate this impact, driven by both corporate social responsibility and government requirements. Green data center is possible by firstly optimizing every aspect of energy consumption. This includes power usage effectiveness, PUE, improvement. A lower PUE, closer to 1, means more of the energy is used for computing rather than overhead like cooling and power delivery. This can also be achieved by using efficient IT equipment, like using your server, storage, and networking gear that consume less power while delivering high performance. Next, we have liquid cooling, which is more widespread adoption for efficiency now. Why is liquid cooling important? Because air cooling, the traditional method, becomes less efficient as server power density increases. Liquid has a much higher thermal conductivity than air, making it far more effective at removing heat. The direct-to-chip cooling uses liquid to circulate directly to a cold plate attached to high-heat components like CPUs and GPUs. This is very effective for targeted cooling. Edge computing. They are bringing computing closer to the data source. Instead of one large central data center, computing is distributed across numerous smaller, geographically dispersed edge locations. They can reduce latency as data doesn't have to travel very far to a central data center for processing, significantly reducing response times. These are crucial for real-time applications. Automation and AI in management. Using AI for optimizing operations, power, and cooling. We have the AI Power DSIM. They make use of AI and AI algorithm to analyze vast amount of data from sensors like your temperature, humidity, power consumption, and airflow to identify patterns, predict failures, and recommend optimal settings for cooling system like adjusting your fan speed or your chiller temperature. AI can also anticipate equipment failure by analyzing performance data, allowing for proactive maintenance, and it prevents costly downtime. We call it predictive maintenance. Modular data center. These are prefabricated scalable units. Prefabricate components like modules for the IT, power, or cooling are built and tested off-site in a factory setting, ensuring quality control. They are scalable as modules can be deployed individually or combined as needed, allowing data center capacity to be scaled up or down incrementally, avoiding overprovisioning. provisioning. With that, I will end my slide. Then we will go to the Q&A session. You can use the Q&A function at the bottom of the Zoom to ask a question. What are the common provider of PMS and especially DSIM? We have, you mean the supplier? We have provider like the Vertiv. DSIM also classified as for training and for interfacing, you mean? DSIM, what do you mean by RDC also classified for training and for interfacing? Data center is, we have training course for data center. Okay, then data center are actually where you house all your major IT equipment, like your server and your racks. So what are the common provider of BMS? Okay, this one answer. Okay, what mechanical engineer roles in data center industry other than cooling, fire, and HVAC system? Okay, for mechanical engineering, mostly they will support the cooling, the fire, and mostly the cooling and fire. So for mechanical role, unless there is A&A projects going on, and then they will ask you to help out with the A&A project. They need expansion. Then probably the mechanical engineer will be roped in to help out with the A&A portion, as well as you need to help to do some monitoring. And then there are times when your mechanical engineer will also have to do codes. You have to source out for your equipment. You might be asked to do code quotation, and then you will also need to escort your vendor to the data center, and then to monitor their work, how is it done, whether they are doing things in a correct SOP. How is data center industry future in Singapore in 10 years? Okay, so we are looking at hyperscale data center now. So there will be bigger data center. They will need to expand the data center because of hyperscale data center, because of AI. So in 10 years time, I think there will be more and more data center coming up because we have more and more requirement of AI. And then the power to support this data center will also go up. How is hydrogen used in data center and what are their benefits? You mean the hydrogen gas for firefighting or for detection? Because we also have detection of hydrogen. And then there's also like your firefighting for fire suppression. I'm not very sure whether they use hydrogen for the gas suppression system, whether it is part of the gas. SDS stands for static transfer switch. Static transfer switch is to switch. They can monitor the switching from the they are for your PDU, to your server. So they will serve the PDU and server. They will make sure that the power is stable for your offstream, the server and the load. They are called the static transfer switch. Okay, beside water, we call it dielectric fluid. So dielectric fluid can have oil and have special liquid inside, so that there won't be corrosion for the liquid cooling. Not only that, and then we call the liquid cooling, we call it coolant. So this coolant, they have higher connectivity than your normal water. I hope that answer your question. I have answered most of the question. Is there anything else you all want to? We try to avoid anything to do with water in the data center. If we are talking about firefighting, so we try to use gas suppression system, and we try to use gas suppression system like NOVAC 120 or FM 200, because gas, they will not damage your sensitive IT equipment. Water mist were very small water droplets. Depending on how sensitive your IT equipment is, normally we do not do design with water mist system as the first design in mind. We will try to use as much as possible the gas suppression system. What specific measures or workaround are in place here in case of critical event like fire or explosion? So we have monitoring system, because one of the things that data center is afraid of is fire, because fire can damage our critical IT equipment. So in order to avoid situation like fire, there is a smoke detection system, and then they will send, let's say if there is a trigger in the smoke detection system, they will send a signal to the SCDF, and then they will come over to fight fire. So we have a robust fire detection system in the data center, but sometimes accidents still happen. There will still be fire. We also make use of sensitive fire detection, like your Vesta system. They are very early smoke detection system, which can help to detect any sign of smoke. Okay, so what are the current types of data center differences between the current types of data center and AI data center? So basically, AI data center, right, you need to have more floor areas, because when we talk about AI racks, we are talking about very big racks. They are very their height is higher than the normal racks. So one of the consideration when we design AI racks in a data center, we have to consider the floor space, the height of the room, to see whether we can have the AI racks in the room. So these are the consideration for AI racks. You have to consider the cooling, whether you need raised floor or non-raised floor. So these are the example of the differences when you house your AI racks and your normal racks. Other than that, all the data center nowadays, they are moving in the AI racks into their data center. So they will need more power, and then they will also need water to help to cool down these AI data racks. For business continuity plan, data center mandate by law to have mirror site across geographical area. I don't think for now, I'm not very sure about this, but I don't think data center mandate by law to have mirror site.
Hi everyone. Are there any more questions that you may wish to ask our speaker?
Oh, there is no dress code when for entering data center. If you are working as a vendor for data center, you might want to consider your you might need to consider whether you want to wear proper PPE. That means your protective gear into the data center. But you must be invited if you want to enter the data center, because you cannot just enter the data center without being invited. Some of your answer I have type in and answer to you. Some I need some to elaborate more about what is it that you all are asking? What is the common accident in data center? Okay, so according to the analysis by Uptime, a lot of the common accident in data center have to do with human accident. That means maybe human errors, and then it can be when you talk about common accident, right? We are talking. Are you talking about what kind of like things that can happen in a data center? It can be like power outage. These are quite common, some in data center, and there is also fire in the data center. Although all these are reducing, the numbers are reducing. So are M&E engineers in data center mainly employed by the hyperscaler or uh, people who own and collect rents? It will depend. Uh, when you talk about depending on the types of data center you are talking about, let's say if you are talking about those colocation data center, then they will have their own M&E engineer within the data center. But let's say for IT equipment, all that, then the uh, the client, the customer will want to engage their own engineer to for the IT equipments. Then for depending on what type of data center you're talking about. So for the enterprise one, right, they will have their own in-house M&E engineers. uh, the career prospect in data center, nowadays, data center, they are building more and more data center. So there's a lot of career prospect for data center, like your M&E engineers, IT engineers also. We also have work study diploma in ITE that will that provide trainings for ITE student. We work with the industry, then we provide training as well as they have on-the-job training. This will help them when they go back to the company to work.
Hi everyone. If there are no more questions, we'll be ending the workshop soon. So please just enter in your questions at the Q&A at the bottom of the Zoom if you have any more questions before we end.
Okay, on the same floor of a data center, does all the rack place in the same place? So if fire happen, the whole place will be affected, or the space will be separated by concrete. So let's say for the same floor of a data center, the rack will be placed, let's say if you have a rack in a room, they are placed together. So if there is fire, there will be gas suppression system that fight the fire. But let's say if the fire cannot be contained, it can spread to the other room. But for the other room, they also have their own gas suppression system. Okay, then when you talk about will it be separated by concrete, it will depend on where the rack is in the room. This can be separated from different rack can be separated by different rooms or by cages. So let's say if there is fire, yeah, there's a possibility that it might, if it is not contained, it will spread to the other racks. That's why we must have very robust gas suppression system to avoid this from happening.
Hi everyone. If there are no more questions, we'll be ending the session. Thank you for all for attending the workshops. So thank you. Thank you, Leng Koon.
Thank you very much. Thank you. Thank you everyone for attending today. I hope I have I hope you have a solid understanding of data center after today. Thank you. Bye bye.